Hybridization. The process by which two or more orbitals combine to form covalent bond is called hybridization. What is central atom? The atom in which hybrid orbital or form is called central atom. Example. In CH4, C is the central atom. Now let's learn about hybrid orbitals. If there are two orbitals, the hybrid orbitals are sp, and its geometric shapes will be linear. If there are three orbitals, the one is s and two are p hybrid orbitals. Its geometric shape will be trigonal. If there are four orbitals, one is s and three are p hybrid orbitals. Then its geometric shapes will be tetrahedral. If there are five orbitals, one is s, three are p and one is d hybrid orbitals. Then its geometric shape will be trigonal bipyramidal. Let's solve a question of sp hybridization. Show the structure and bond angle beryllium chloride molecule. Here, central atom is beryllium. Its electron configuration is 12-2s2, 2p0. In excited state it is 1s22s1, 2px1, 2pyo, 2pz0. So it is sp hybridization. Bond angle of sp hybridization is 180 degree. Structure of beryllium chloride is linear. Here is the figure of it. 2. Explain the hybridization of NH3. Here central atom is N. Electron configuration of N is 12-2s2, 2px1, 2py1, 2pz1. From the above electron configuration we get in NH3, sp3 hybridization is present. Where N has 4 hybrid orbital with 3 hybrid orbital, where every one participate in head-to-head overlapping with H atom. So at central it has one lone pair electron and its shape is pyramid, where its bond angle is 107 degree. This is the figure of NH3 hybridization. 3. Explain hybridization of H2O. Here central atom is O. Electron configuration of O is 1s22s2, 2p4. In excited state it is 1s22s2, 2px2, 2py1, 2pz1. So in 2s and 3, 2p orbital produces 4 hybrid orbitals. As a result sp3 hybridization is noticed. But 2 hydrogen will get attached with oxygen to produce H2O. The lone pair electron in the outer shell will apply pressure to bond pair electron making 104.5 degree bond angle. And the diagram will be like this.